Good evening, everyone, and Assalamualaikum, Azani. Okay, we will wait for the other students to come in. We still have 5 minutes.
Okay, Prof.
Okay. Okay, good evening, everyone. At least Malaysia is in the evening. It is 8 o'clock in Malaysia. So, Jaime, I think we call it Jaime, is it? Castillo? Christopher, Jefferson, Mariam, Nadira. So how are you? Hope everybody is okay. Okay, today we in the lesson, in your notes, I've given to you topic 3 and topic 4. Actually, we will run through topic 3 and topic 4, but we only have 2 hours. So I will run through quickly, but anyway, I will upload my iLecture. In the iLecture, I will give more detail. Yeah, I'll give more detail. Anyway, please read the book. So on the ODL, we cannot give so much detail due to the constraint of time. So anyway, you can always ask me question in email or in the WhatsApp group. I see we have formed a WhatsApp group. You can always ask me. Okay, we will start the topic on today. Our topic is on descriptive analytics. It's about data. So I'll share my screen. So students are still coming in. It's okay. You can just join in. Okay, the topic today is about topic 3 is about descriptive analytics. It's about data. What is data? Nature of data. Okay, let's see. Okay. 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 So we begin where I need to start. Okay, topic today is on topic 3. So it's about data, about descriptive analytics. Before we move into descriptive analytics, we will talk about data, the nature of data. So when we gather information, before we gather information, we gather data first. There are 3 layers for information. Okay, I'll just put it I give you a whiteboard. Okay, I'll just see my whiteboard. At the bottom, we have data. Data are just raw facts. They are just signs, symbols. Yeah, signs, symbols. And then data has no meaning. Yeah, data doesn't have any meaning. So we talk about data. So before we do analytics, we need to look at data. We need to understand what is data. Data are just raw facts, signs, symbols, anything that you capture very, very raw, but it doesn't have any meaning. It doesn't connote any meaning. When you integrate data, we have information. Information is integration of data. Meaning data combined with data we combine with other things, summarization and so on. So we have it provides some meaning. So information is at higher level from data. We process data, it becomes information. We integrate data, become information. We consolidate data, become information. Yeah, so we combine data, become information. This information provides some meaning. But we still cannot act upon it. We need to have knowledge. Knowledge is the higher level, which is the combination of data, information, and experience. So this is what we call actionable information. Actionable information. So knowledge is actionable information. We can act on knowledge, but we cannot act on information alone. And then we also cannot act on data. Data doesn't have any meaning. So at higher level, we have information. At the highest level, we have knowledge. And then the highest level, we have what we call wisdom. Wisdom is integration, is consolidation of knowledge. Yeah. Okay. This is for now. And then now we move back to our slide. We talk about data. Data are collection of facts, observation, and sign symbols. Yeah, these are raw. Data are raw. Yeah, so we collect, usually raw. So it can comprise of numbers, words, images. There are two types of data. Basically, there are. I think I need to go back to my whiteboard. There are two types of data. Now we understand here what is data, what is information, what is knowledge. Okay. Any question you just ask. Yeah? So if anybody not clear, just ask. So that before I go on. Okay, there are two types of data. There are two types of data. We have structured data and unstructured data. Yeah.
Please also send a picture of Batu stores and a picture of South Africa like an app, because we need to.
Yeah, structured data and unstructured data. And unstructured data. Okay, these are not in the book. Yeah? Structured data are data that are in proper structure, proper exact length, format, specific format, meaning there is a specific format, and then length, etc. Yeah? So these are structured data. Unstructured data, there is not unspecified format. So there are two types of structured data, which are machine-made data, machine-generated. I break it, I need to draw. Machine-generated. And human-generated. Meaning that machine-generated structured data, meaning that, for example, your QR code that when you purchase things, the barcodes, it is proper structured. So, but it is machine-generated. The data is captured, properly structured. Yes, so machine-generated or human-generated, where you key in forms, specific forms, name, date, month, year, something which is properly structured, that is human generated. Yeah, or we can have unstructured data. Unstructured data, they could also be machine generated. For example, satellite signals, maybe certain movement in your ECG, EEG. So this is machine generated, but it is unstructured. So it can also have a structured human generated data, unstructured human generated data, human generated. What are unstructured human generated? For example, articles that you write, text, you write up, your emails, the top portion are structured, but the bottom portion where you put the content, those are unstructured. Images, drawings, so that those are human generated, but unstructured. Okay, now you understand what is data. Data comprised of structured and unstructured data. And then unstructured data could be machine generated or could be human generated. Yeah. And unstructured data could also be machine generated or human generated. Yeah. So earlier we talked about data. information, knowledge, and wisdom. Now, specifically on data, data doesn't have meaning. Data doesn't provide a meaning, right? Data can be structured or unstructured. And then this structured data can be machine generated or human generated. Yeah. So same goes with unstructured data. It can be machine generated or human generated. That's okay. Now we move back to our slide. So data is just collection of raw facts. Yeah, I need to put here. It is raw facts. Yeah, doesn't have any meaning. So it results from observation. So how do you get this observation? Observations come from usually we have variables, things that interest us. What do we want to look at? That is in did I have that? Okay, no, I don't have that in my notes. So we look at we have variables. Yeah, variables are things that we are of interest, meaning that observations that interest us, that we want to look at. So it derives from observation. Yeah, from observation. So from observations, we are figures that interest us, meaning that we are interested to look at. So these are variables. So data are raw facts usually collected from observations. Yeah. So it can comprise of numbers, words, images. So it can be numbers, can be structured or unstructured. Yeah, can be machine generated, be human generated. Words could be machine generated, human generated as well. It could be unstructured, could be structured or unstructured. Yeah. And then it is the lowest level of abstraction, and data is below information, and then of course it below knowledge. Yeah, data is the lowest. After on top of data, when we aggregate data or consolidate data or integrate data, we get information. When we combine information, we have another information, and we add on understanding and experience, we get knowledge. So data is the source for the information and onward to become knowledge. So for analytics, when we're talking about business analytics, so data quality and data integrity is important to our analysis for our purpose. It's important that we must maintain data quality and data integrity. Yeah, so move on. So where do we get our data? So in business operations, we get our data from our business processes. What are business processes? Business processes are a collection of routines. So we have business routines, we combine business routines, we have business processes. So from our business processes, for example, purchasing process, procurement process, or production or sales process, yeah, sales business process. Yeah? So we have routines, meaning delivery of sales order, sending purchase orders, and so on. Yeah, so those are routines combined with a business process. So from the business process, we have the data that is being collected by what we call it TPS. Besides ERP, CRM, and SEM, we also have TPS. TPS is transaction processing system. Transaction processing system. Example of transaction processing system include your point of sales, your automatic teller machines. So these are transaction processing systems. And then from this, we have MIS. Some components of MIS include your ERP, enterprise resource planning system, customer relationship management system, CRM, supply chain management system, SEM, DSS, and others, KMS, knowledge management systems. So this involves business processes. So data are collected here. These are data from your business processes, business operations. Yeah, so your daily business activities, you collect data from here. So some of these might be structured, some of these might be unstructured. For example, emails that you receive, there are components of structured, components of unstructured. It's called semi-structured. There are transactions that you collect from your point of sales that is structured, that collected from your automatic teller machine, for example, ATM. Yeah, so it is structured. So there are structured, there are unstructured. And then besides the business processes, you have data that comes from your internet, from the social media. Today we have Instagram, Facebook, LinkedIn, YouTube, Tumblr, Reddit, Foursquare, and so on. Yeah, WhatsApp, and so on. So these are data that is being collected from your social media. Mostly are unstructured data. Images that you capture, yeah, and then you put in your Instagram, the label that you put into your, or tagging that you put into your images, it's called metadata. So these are unstructured data collected. And then we have machines, yeah, Internet of Things. We have sensors, actuators, we have tools at your devices, yeah, at your operations. So these are machines, Internet of Things. So some could be structured, some could be unstructured. So all this data will be processed here to perform your analytics. So we have data storage. Last week we covered the how we build data warehouses. Yeah. So we move into data warehouses. We have data mart, we have data warehouses, we have independent data mart, we have dependent data marts. Yeah, this is where you kept your data. And then you will perform analytics. In order to perform analysis, we must make sure that the data that we collected are of good quality and are integrity, have integrity. Yeah. So you will use this analytics to produce knowledge, yeah, to understand patterns and then to see trends so that we can make business decision from this. Yeah. So these are the nature of data. So where the data come from. Okay.
Excuse me, Prof.
Yes.
Sorry, Prof. The previous slide, please.
Okay.
Yes, Prof. Prof, I wanted to ask you in terms of data, because probably it's an obvious question or it's an obvious statement, but we know that for thousands of years, people have been collecting data, maybe not in data in terms of computers, but in terms of logbooks. Exactly, probably they have been doing the same thing. The business has been doing collection of data. They have been doing analysis of data. So what is the importance of why everybody keep talking about business analytics? There's so many jobs, but this has been done for years in the past. Is this because of the amount of data, or is it because of the computing, or because of the internet? It becomes so important, data analytics.
Okay. Okay. I get your question. Maybe just I will give my answer, but you will respond whether I respond to your question or not. Okay, why do we have business analytics? In the first class, actually, business analytics come forth because we have internet. We have tools. Okay, earlier we have relational database management system where we collect data. And then we have more and more data. We have data warehouses. We have data warehouses because we want that from these data warehouses. It's just this. With the advent of relational database management system, the purpose of relational database management system is keep track of your business records. You have a lot of business records, so you keep track of your business records. So you want to see trend last year, this year, last month, this month, and then you just collect it for your day-to-day business purposes, day-to-day running business purposes. And then from this gathering of this data get bigger and bigger. We coined the term data warehouse because the data gets bigger and bigger. Now we have data warehouse. So it provides an opportunity to us. It's an opportunity to us. When we have data warehouses, so why don't we look at the previous trend? Because maybe there is a cycle. And then can we look at associationship? Because if people buy this, where people will also buy another item. If people buy A, will also buy item B. And then can we also cluster this trend of people who purchase what? So from this data warehouse, we are able to do what we call, initially we call it business intelligence. Business intelligence is looking at what we have, and then so that we can have some insight of the data that we have. Business intelligence, yeah, business intelligence. And then come the internet. Come the internet, we have much more data, much more data. So we look into opportunity. It is not about tackling problem, actually, it's more of opportunity. That's why when in the second class, the second lesson, yeah, last week, when I talk about why we develop business intelligence, because of opportunity. Okay, now we have opportunity. With the internet, we can have more, but too many data make ourselves confused. Which data we want to select and so on. And then we have terms like extract, transform, and load, and so on. We have this kind of thing. And then coin the term business, we call it predictive analytics. So we can see the trend from the previous descriptive analytics. And then we have this, that we have the term prescriptive analytics, so that we can make decisions. So, and then all in all, it is all about data. So this class today is about how do we understand our data. We have some data can be useful, some data can be useless. So which data we want to use? It's about us understanding our data. We will start with this class today is about descriptive analytics. It's the beginning. We just look at the current data first. And then the next topic 4 will be data mining. We look into insights. So we can do some predictive, so trend and so on. Does that answer you, I mean?
Yes, thank you, Prof. I really appreciate it. Thank you.
Okay. So this is the data that we have. Yeah. So we have TPS. This is where we collect our data. Data comes in every time comes data. When we do selection, we call it data warehouse. When we don't do selection, we just put everything to get all in a repository. We call it data lake. But we don't focus on data lake for now. We just look at data warehouses. Yeah? So this TPS, this is data warehouse that we talked about last week. Yeah. So now we want to make sure that we have the right data. We have the right data. I mentioned earlier that we need to look at the data that we have must be of good quality, must be integrity, must have integrity. So we look into the metrics for measurement or to look into ready data. Data is ready, which are ready for our analytics. These are the metrics. We need to have data source reliability. The data source must be reliable, meaning that the originality, the appropriateness of storage medium, where the data is obtained must be reliable. So we look into the original source of this data. Yeah, so the original source of the data, who are the creator of this data, and then whether there could be some data misrepresentation, meaning that they misrepresented the data, and then we put the data in, and then it cause erroneous result into our processing. So we look into data source reliability. So our data source must be reliable. So we maybe in terms of including the format. The format, maybe you have date, month. Remember, we have, when we key in, this is DD, MMM, and then YYYY, for example. Or the other way, where is MM/DD/YYYY. So data source also, data formatting must also be accurate. So data source is reliability. And then data accuracy. Data accuracy means data must be correct. Yeah, so it serves the purpose of the analytics. Yeah, so you want to process it for certain analytics purposes. So when we talk about the previous class, we talk about problem. Yeah, so data, we are looking into business. It's not so much of the requirement. There's not so much of system requirement, but look into business requirement. In terms of business requirement, what are the accuracy of this data that we require? Yeah, the accuracy of this data must be good match to the analytics problem. Must be according to the intended and defined original source of this data. And then data must be accessibility. So data must be obtainable. So how you can get this data? So that data can come from the different location. It can be from your ATM, automatic teller machine. It can be from your POS, point of sales. It can be from the internet. Today we do transactions over the web, internet. Maybe we have e-wallet or cryptocurrency. So this data must be accessible to us. We have to plan so that this data are accessible. And then data must be secured. So only those people who have authority and the need to access can have access to this data. And then data must be privacy. They must maintain the privacy of data, meaning that data belongs to individuals. When we do data, we don't do what we call it row-based analysis. We do column-based analysis. In the table, actually, when you do relational database management, relational database, the column-based, and then we include the name, include the name and identity. So it is, we call it de-identified data. The term is de-identified data. De-identified, or we call it columnar data. Columnar. Meaning that we don't look at the person. So we maintain privacy. De-identify, we remove the name and so on. So and we just look at the columnar data, meaning that we don't look at the row. Yeah, the individual's names are in the row. Yeah, so data must be rich, meaning data must be include. Richness must be suit enough, must be rich enough for the purpose of the analytics. Yeah, actually this is also, richness is also, what do you call it, subjective. Yeah, depends on the richness will depend on the need. So what is the level of richness that we require for the purpose of the dimensionality? We talk about dimensionality in the other day when we look into Snowflake, yeah, to dimensionality of this data. And then data must be consistent. Yeah, data must be consistent, meaning that must be accurately collected, combined, merged, must represent the dimensional information coming from the from disparate resources, from the various resources that we get. Data must be current, meaning that the data, we cannot use data. Today is 2023. We cannot use data is 2013 or 10 years old. So data must be current, data must be timeliness for our business purposes. We are doing business in 2023, so this data must be relevant to our current business. And then we also look into granularity of data. Granularity concerns the coarse and the fine. You can have a very fine data or coarse level data. So it depends on the need. Depends on the need of data. And then data must be validated, meaning that you must make sure that the value range and so on is correct. And data must be relevant to the variables. We have variables, observation, data must be relevant to the variables that we are studying. So these are the metrics of data that we will use for our analytics. Yeah, so then we will have cleansing of data and so on. We have correction of data to make sure that our data collected, the data source are reliable, the data content is accurate, data are accessible, there is security of the data, we maintain privacy of the data are sufficiently rich for our purpose, our analysis purpose. Data consistency, meaning that there is coherence of data between the super data and sub data. And then data are current. So data that we collect are timely. And then we maintain the granularity of data according to what we need. Yeah, we can very coarse, we don't have anything, or we can very fine, we have too detailed. And then data need to be validated, and then data must be relevant to the variables that we want to do our research. Yeah. So this is simple taxonomy of data. Yeah. When you look into data in analytics, okay, this is one I mentioned just now. We have structured data, we have unstructured data or semi-structured data. Okay, I have mentioned structured data, I have mentioned unstructured data. So what is semi-structured data? Semi-structured data is a data where you have combination, partially structured and partially unstructured combination. Because for example, your email is a semi-structured data because the top portion, the sender, the recipient, the date, and the title, those are structured, but the content of your email are unstructured. You can write anything you like. So it is unstructured. So there is in total, your email is a semi-structured data. So structured data, it can be nominal data. Yeah, it can be nominal data. What are nominal data? Is okay, it's not here. Okay. Nominal data is data that are very simple. For example, like male, female. Yeah, so we have nominal data. Yeah, so this is nominal data, male and female. Nominal data or ordinal data. Data can be categorized into certain level, meaning that you have low, medium, or high. This is ordinal data. So these are called categorical data. We break our data into categories, meaning we have nominal data, male, female, or Caucasian, European, and so on. So we break them into nominal, into categories, nominal. Ordinal, we can have low income, high income, or we can have toddlers, teenage, adult, and so on. So these are categorical data. Or we can have numerical data. Numerical data, we can have interval data. The normal interval data can be measured on interval scale, or ratio data. What ratio? And so these are structured data. Unstructured data can be textual data, text, written text. We need natural language processing to process this data. Multimedia data, which can comprise of image, audio, video, or XML data. XML are codes. XML stands for Extensible Markup Language, or JSON. JSON is JavaScript Object Notation. It's actually machine can talk to another machine with using these two languages. It can either be XML, Extensible Markup Language, machine, or computers can talk to another computers, or JSON. JSON is JavaScript Object Notation. I'll write it below here. XML is extensible or JSON is JavaScript Object Notation. This is meant for computers talking to another computer, machine to machine. So with schemas, we can translate the XML and JSON into a proper understanding by the machines. Okay, that is. Now we move into data. Data are facts, figures, collected, analyzed, summarized for presentation, interpretation. Variable is a characteristic that we have interest on. Observation is a value that correspond to a set of variables. And then variation is the differences in the over the observation. We see variances, fluctuations of the variables. And then we have a random variable or uncertain variables, which is value, which we don't know, and for certain, which is uncertain. Okay, Now we understand just the basic of the nature of data. Now we move into type of data. Yeah? We have data. We usually do not look into population of data. Population is data covers everybody, covers everyone, or covers all elements that we want to analyze. But usually we collect data from population. We call it sample. Yeah, sample is a subset of population. So we can have random sampling. So we collect. There is a specific method of doing sampling, maybe stratified sampling, random sampling, how to collect data. And then there are two types of data. We call it quantitative data. Quantitative data is data which we can operate. Which we can manipulate using mathematic processes like subtraction, addition, multiplication, and division. So these are quantitative data or categorical data. Categorical data, for example, male and female, and so on. Yeah. And then we can have cross-sectional data that is be collected across several entity or at the same entity, but across different point of time. Yeah, different at the same point of time, or time series data. Yeah, data collected over several period of time. Yeah, cross-sectional and time series data. So sources of data can be from experimental study. We want to do a study, we collect data from experiments, or it is non-experimental or observational study. So we can look at data for over a period from our observation. Yeah. So data preparation. So how we prepare data? like I think, like we mentioned, based on Jaime question just now, we have a lot of data collected, but most of data are dirty, misaligned, overly complex, inaccurate, so they are not ready for analytics. So what do we need to do? We have data pre-processing. How we consolidate this data? We need to clean the data, transform the data, and reduce this data. So this process is an art that it develops over time, and we will improve it through our experience. So what are the processes? So yeah, so in data reduction, okay, these are processes. Data consolidation, we collect data, we select the data, and then integrate the data. And then in terms of data cleaning, we impute the values, we look at the values, we reduce noise, we remove errors, we eliminate duplicates, we transform the data, we normalize the data, discretize the data. Discrete meaning that 1 or 0, so discretize the data. We create the attributes, and we reduce the dimension, reduce the volume, and balance the data. Yeah, so we have this is variables. I will not go into detail. So and then data consolidation. How do we consolidate data? We can access and collect this data, select and filter the data, integrate and unify this data. What are the tools we can use? SQL queries. SQL stands for structured query language, SQL. Structured query language. So you can do SQL queries to consolidate this data. We can use software agent, or you can use web services. Web services, I don't have time to go detail, but web services is how web can communicate with another web using service-oriented architecture, and then applying XML or JSON as its language. Yeah, so how do we consolidate? We require domain expertise. Domain expertise can be, for example, finance expert, yeah, accounting expert, yeah, HR expert. So they have this, and then with these domain experts, they will combine data according to the subdomain, according to the proper dimension. Yeah, we use SQL queries, and then we can do statistical tests. For example, we can do hypothesis testing. Yeah. So this is for selection and filtering the data. Yeah, we do domain expertise. And how do we integrate this data? We also use SQL query. We also use domain expertise and ontology-driven data mapping. Ontology-driven data mapping. Ontology is a sort of categorization of data. We categorize data. Yeah, ontology-driven. For example, we classify them into the student, lecturer, or the basic thing that you can remember ontology is taxonomy. Reptiles, mammals, birds. So those are ontology. So break them into their classes. Break them into classes so you will be able to integrate and unify this data. So this is what we call data consolidation. Okay, now we move into data cleaning. So how do we do data cleaning? We handle missing values in the data. So we fill in missing values with most appropriate value. We can by mean, by median, minimum, maximum, mode, and so on. Okay, or you can recode the missing value with ML, yeah, or remove the whole record of the missing value, or just leave that, depending on the analysis that you need to do. That is handling missing value. And then you need to identify and reduce noise in the data. Yeah, identify the outliers in the data with simple statistical techniques. Actually, this task actually I provided the notes here, and then in my lecture I will show you an Excel process and also R process, R programming process. How do you do this data cleaning? How do you remove the noise? How do you identify the outliers? How do you look into missing values? Yeah. So identify noise, reduce noise in this data. I will just go quickly for this topic because I have many slides to go. Yeah. So, but you please watch my video. I'll upload my video soon, and then you read the notes. Yeah. And then how do you find and eliminate the erroneous data? And then how do you how do you normalize this data? Data transformation, you normalize this data. And then discretize this data. Discretize data is putting into bins. We have bins. I'll cover bins later. Yeah, I'll just go quickly. I'll cover bins later because we are out of time. And then we construct new attributes. And then how do we reduce the number of attributes? Sometimes we have too many attributes. We can reduce the you do chi-square testing and so on, correlation analysis to reduce the attributes and so on. So when we talk about business analytics, yeah, we go back from the first class. We have descriptive, predictive, and prescriptive. So this is the part that we do. Besides online analytical processing, we do statistics. From the statistic, we have descriptive analytics and we have inferentials. Inferentials, we can do inference. Yeah, we'll cover that. So do we have statistic is a collection of mathematical techniques to characterize and interpret data. And descriptive data is about describing the data as it is. And then inferential, that statistic is about drawing inferences from the population based on the sample. So like mentioned just now, we are not looking at the whole population, but we are taking a sample. From this sample, we infer, or we call it, we infer the knowledge, the result, or we infer the information into the population. Yeah. So descriptive statistic is meant for descriptive analytics. So how do you create distribution? So you have frequency distribution. So we have bins. Yeah, this is distribution. For example, this is an example. So this is some example. I will put up this example in your notes in your LMS. Yeah, I will even put up the how you work this using Excel. Yeah, I'll record how do you do this in Excel using Excel, so that you will be able to collect data, to have this data, and then put them into bins. This is the bin for Coca-Cola, bin for Diet Coke. Yeah, so what is the frequency? Put them into bins. From this frequency, you can have frequency distribution. Yeah, and then we have relative frequency distribution. This is a relative frequency distribution between the other, yeah, percentage. Yeah, so it provides understanding to what is the maximum frequency. It's 38%. which is Coca-Cola, for example, and out of 30, 100. So this is how you calculate the, how do you develop the frequency distribution? Yeah. So this is the frequency distribution. Yeah. How do you calculate the frequency distribution? You have the largest data value, smallest data value, and you break into number of bin, and the number of bin that you want to set up. Yeah. So I will provide you the videos for this. So this is the frequency, relative frequency, and percent frequency. This is how you do the frequency in Excel. Frequency distribution in Excel. This formula in Excel. I will also provide you how you do this in R in the video. Histogram. I think everybody familiar with histogram. Histogram is the graph, and then from histogram you can have skewness. Moderately skewed to the left, moderately skewed to the right, and then this is symmetric, this is highly skewed right. And then you need to look into also in terms of kurtosis. And then this is cumulative frequency distribution. This is how you do the frequency distribution. Measure of location. We have, in terms of measuring the location, there are two things. One is the dispersion, one is the location. Location, we look at the mean, median, mode, and geometric mean. So this is how you calculate your mean. This is a review of what you have done in your school or undergrad. Yeah? This is mean, arithmetic mean. There are two types of mean, arithmetic mean and geometric mean. Yeah. So this is arithmetic mean. I will provide you the video, also the data for this. You can test it. You can do it on your own. Median is the middle figure. Mode, which is the most highest occurrence, mode. Yeah. This is the formula if you use in Excel. And geometric mean. Yeah, geometric mean is location calculated by the root of the value, instead of the compared to the arithmetic mean. Yeah. Okay, now I will move quickly because we are coming to 9. Okay, in terms of variance, variability, dispersion, we look into range, variance, standard deviation, and coefficient of variation. Yeah, so this is the measure of variability. Yeah, so, and then this is the computation of range. Yeah, computation of range. What is the range? The lowest value, largest value, and then variance is this is sigma. Population variance sigma divided by n, and then with sample variance divided by n minus 1. Yeah, when you take sample, it's always minus n minus 1. When variance is n, the total population number. So this is the sample variance. Standard deviation is the square of the square root of the variance. Yeah, square root of the variance. This is how do you calculate using Excel. I will also provide in the video how do you use R. Coefficient of variation is description of the data compared of the standard deviation in relative to the mean compared to the standard deviation divided by mean. Yeah, arithmetic mean by the arithmetic mean. So this is class data. So this, and then when you look into this, analyzing the distribution, how do you analyze distribution? It can be percentiles, quartiles, z-scores, empirical rules, identifying outliers, and also box plots. So this percentile, you divide them into 100 percentile. Yeah, this is some figures. Just look at your notes. Quartiles, you divide into 4, meaning that 25% each, every quartile. Z-score, you look into the relative location in the data set. We call it standardized value. So xi minus the mean of x divided by the standard deviation. You have the z-score. This is an example of z-score. Yeah, this formula for z-score. Yeah, and then this is symmetrical bell curve in terms of z-score. When you look at outliers, you can look into data values that score less than -3 or greater than 3. Yeah, outliers. This is box plot to provide graphical summary on the distribution of data. Yeah, the median is in the middle. This Q1, Q3. And then this is how do you do this using Excel. I will provide the data and I will provide a video. How do you do this? I'm still doing it. Yeah, still recording it. Yeah, box plot. And then how do you measure association between two variables? You can be using scatter chart, covariance, and correlation coefficient. Please read. Yeah. So this is measure association between two variables. Scatter chart. So this is an example of scatter chart. Relation between sales and high temperatures. And then covariance, you can see the relationship between two variables with the means. So this is as positive, variance, covariance. This is scattered, not linearly related. So this is as negative. Yeah, the C is X negative. Correlation coefficient measure the unit between the correlation coefficient, the covariance, and the standard deviation. Yeah, standard deviation. This standard deviation. This is covariance. Covariance divided by standard deviation of X and standard deviation of Y. So if it is less than 0, meaning it's negatively linear. Near 0, no linear relationship. More than 0, meaning this line positive linear. So you can see the strong linear between the covariance. Data cleansing. How do you look into data cleansing? You look into missing data. I will provide the example of this in the video. Yeah, how do you cleanse data? How do you look into to discard observation with any missing value? And then there are types of, which is missing completely at random, or missing at random, or missing not at random. So missing completely at random is where observation are totally missing, is entirely random. Missing at random meaning tendency to be missing at the certain some variable which is related to certain value. Not a random tendency to be missing related to the specific value that is missing. Yeah, imputation is where you replace the missing value, which is reasonable. You look into reasonable. Okay, I will provide you video into this. I'll provide you the data as well. Yeah, so because I need to move into the next topic. Okay. Okay, now I'll move into data visualization. Very sorry, I have to go very fast. We only have another hour to cover. Okay, data visualization is where, okay, this is related to your group assignment. You need to do visualization on a dashboard. So data visualization involves creating a summary table or generating a chart to interpret, analyze, and provide, learn from the data. It can help us to identify data errors and also reduce the data set so that we can see relationship data and trends in the data. So overview of data relationship. So this is the concept developed by Edward Tufte on data ink ratio. So when you develop, when you're designing your data visualization, there is a ratio, we call it data ink ratio. So we reduce the ink that is not useful to serve, to provide, to convey any data to the audience. So please go through. I will not go through detail because I need to run quite quick. Okay, for example, this is low data ink ratio. When you to have higher data ink ratio, we reduce it to this. So we remove the line just now. The line is not, because we have tables, so we don't really need to see this line. Okay, tables. What are the tables? The tables, we use tables when we need to specifically refer to a specific number. If we don't require a precise comparison, you don't have to use table. Yes, this is table. So how do you put table? Yeah, you can have tables below here. Yeah. And then avoid using vertical line in table unless they are necessary. Horizontal line are necessary to separate the column titles from data value. For example, this design D. Yeah. Okay. Then we do cross tabulation table that cross tabulate data of two variables. So we can use pivot table in Excel. I will show you a video of to use pivot table in Excel. This is cross tabulation, waiting time versus meal price, cross tabulation. And then you can also use pivot table. This is a pivot table. You can use pivot table in Excel. Okay. Charts, these are the several types of charts. So charts are, or graph, a visual method of display your data. You can have scatter chart, trend line, line chart. Yes, so these are scatter chart. Yeah. Line chart, scatter chart. You can draw a line chart. Line chart again. Spark line. This is spark line. Here at the bottom here. These are spark lines. You can see at the bottom here. These are spark lines. To show north, for example, the fluctuation of north from January to December. South also from January to December. You create spark lines. You can use Excel to do this. Okay, this is bar chart, pie chart, bubble chart, and heat map. This is pie chart, bubble chart. Okay, this is heat map. Stack column chart, clustered column chart, and scatter chart matrix. Yeah, stack column chart. Yeah. Clustered column chart, multiple column chart. Yeah. So this is scatter chart. Then you can use pivots in Excel to generate this. Advanced visualization, we can have parallel coordinates plot, or you can have three map, the parallel coordinates plot, three map. Yeah, this is another three map. Geographical information system, you have a geographical information system chart, GIS. Completed 3D map. Then this is dashboards. Okay, dashboard is data visualization tool. This is part of your assignment that you need to illustrate multiple metrics automatically update. It's based on key performance indicators. Yes, in your assignment, you have key performance indicators that you look into the clinic. And then in your dashboard, how do you put them in your dashboard? There are some principles here. How do you put data dashboard? This is an example of data dashboard. How do you design data dashboard? We can have 3 layers of information: monitoring, analysis, and management. What to look out for in your dashboard. And then the metrics, the best practices in dashboard design. Yeah, how do you benchmark KPI with the industry standard? Metrics with contextual data, metadata, validate the design, prioritize, enrich the dashboard with business user comments, etc. Okay, I'll move into data mining. Can I will give you a break, 5 minutes enough?
Okay,
Yes,
Prof.
Prof.
Yes, bro.
Okay, bro. Thank you, bro.
5 minutes and then we'll continue with data mining. Very sorry. We are very fast today. And okay, just give you 5 minutes, 8:05 and 9:05. Let's start recording. Okay. Okay, we will continue. Data mining. Let's skip data mining. We'll continue with data mining. Okay, where is data mining just now? Okay, the purpose of business and the data just now is for us to be able to mine the data. So we talk about the types of data just now. So the purpose of it is so that we will be able to mine this data. So how come all this can here? So I need to have mining the data. Mine this data. Wait. No, not sure. Okay, we will do what is data mining. Okay, data mining is the actually we find hidden patterns. Actually, the goal of data mining is to look for hidden pattern. Yeah, so we have several data mining techniques. So we are to identify hidden patterns in the in our sets of data. So how does data mining come forward? Is actually like I mentioned to the question behind me just now. Is actually we look into opportunity. When we have large amount of data, we have opportunity. So we have explosion amount of data. So that we have data warehouse today, we have data, and then we have computer power. So with computing power, with the size of data warehouse, and then we have the large amount of data, so we mine the data. So mining data doesn't come out of necessity, it comes out of opportunity. We have opportunity to mine the data. So how do we mine data? We look into this observation. Observation is, like I mentioned earlier, is set of recorded values of the variables associated with a single entity. There are two types of mining data. We call it unsupervised learning and supervised learning. Unsupervised learning is where there is no specific or a priori dimensions identified. And then, but supervised learning, we have a specific dimension that we look at. Yeah. So data mining concept, like I will just skip some of these, so that I can go detail. So definition of data mining. So these are the three definitions, several definitions of data mining. It's much more of knowledge extraction, pattern analysis, knowledge discovery, information harvesting, and pattern searching. It's not so much of mining. So the keyword is data mining can be a misnomer. So data mining is a blend of multiple disciplines. It is about knowledge discovery. So where do we apply? How do we apply data mining? We have knowledge of our statistics, statistics, artificial intelligence, machine learning, pattern recognition, information visualization, data management, database management, relational database, data warehousing, management science, and information system. From the combination of these, we have our what we call today data mining. So most of the time, the data mining comes from consolidated data warehouse, but not always. So data mining environment can be a client server, web-based server. So it is so miner is often an end user. Users mine the data. So we extract, like I mentioned, we extract patterns of data. What are the types of pattern that we extract? We look into association. We look into prediction. We look into cluster, and we look into sequence. Yeah. I'll go detail. Okay, there are this is the basic tools for data mining task. One is prediction. Prediction is based on classification, regression, and time series. Yeah, that these types, this method of classification, regression, and time series. These are, and then the algorithm that we use is decision tree, neural network. I'll go detail later. Neural network, support vector machines, KNN, K nearest neighbor, naive Bayes, genetic algorithm. Yes, and then these three, classification, regression, and time series are supervised learning, meaning that we have a proper method, we have proper classification, and then we classify them. The learning type is supervised. Whereas association are unsupervised. Association include market basket analysis, link analysis, and sequence analysis. If we have a priori, 1R, 0R, we'll go detail later, yeah, on this on the algorithm, data mining algorithm. These are unsupervised learning, meaning that they learn through the data that we collect. Yeah, learn through the data that we collect. And then segmentation. Segmentation include clustering and outlier analysis. Okay, what is clustering? Clustering is similar like classification, but classification is called supervised because classification have proper class. They have defined the class, whereas clustering does not define the class. So we look into k-means, yeah, expected measure maximization. These two are also unsupervised learning type. So other mining tasks could be time series forecasting based on time series, visualization, you visualize, and data mining versus statistic they are related. We apply statistic in our data mining task. So how do we apply data mining in businesses? We can do data customer relationship management. We can look into how do we maximize our return on our marketing campaigns. We do marketing campaigns, and then how do we maximize our return? We can do data mining. How do we improve our customer retention? We look into churn analysis. Churn is the customer that left us and go to another company. That is called churning. So we need to have customer retention. How do we improve our customer relationship? A customer retention, we can apply data mining application, data mining techniques. How do we maximize our customer value? By doing cross-selling and by doing upselling. We can use data mining application. How do we identify and treat our most valued customers? We can also use data mining application. In banking and other financial, we can automate loan application process by data mining. We can detect fraudulent transaction by using data mining. We can maximize customer value, cross and upselling in data mining. And also we can optimize our cash reserve with forecasting, also using data mining application. In the retailing, we can optimize inventory level. We can improve store layout. Yeah, by market basket analysis, we'll go in market basket analysis later in identifying the store layout, optimize logistic, and minimizing our losses due to limited shelf life by using data mining applications. I will go in detail later. And also I'll try to put in much more detail in the video. Manufacturing and maintenance, how we predict and prevent machinery failure, identify anomalies in our production system, and how to discover certain novel patterns to improve our product quality. Yeah, in brokerage and insurance, yeah, I'll go for detail. So we can also use data mining in computing hardware, software, science, engineering, government, defense, and so on. The process involves, there are several methods. The most common standard process for data mining include CRISP-DM. This is applied using R programming. We will be learning R. At least I'll put out some video on R. There is a video already on how do you download and install R, and then I'll put some video on how to use R. SEMA is by SES, yes, SES Incorporated, and KDD, Knowledge Discovery in Database. So this is CRISP-DM, cross-industry standard process for data mining, proposed in 1990 by a European consortium. It involves 6 steps. First is do business understanding, data preparation, build our model, test and evaluate, and deploy the model. It's about, so 85% of the time is actually on step 1, 2, 3. Yeah, we develop the business understanding, understand the business, understand the data, we prepare the data, and develop a model. test, and then we deploy. When we deploy, so whenever whatever model comes in, we can we can do association, we can do this supervised learning. SEMA is by SAS Institute. The process involves sample, explore, modify, model, and assess. Yeah. There is a much more detail right up in the textbook, yeah, on SEMA. And KDD is knowledge discovery in database. It involves extracting patterns, and it involves knowledge management. So we have sources for raw data, we have the target data, pre-processed data, we clean and then we transform the data and we do data mining here. We extracted patterns and then we have knowledge actionable insight. Okay, classification. What is classification? Classification is a supervised learning. Supervised learning meaning that there is proper classes. There is a proper classes that we put our data in. We have data and we have a priori classes. We have a prior classes that we include our data. This is most frequently used data mining method. Is part of machine learning family. Machine learning is part of artificial intelligence. So we employ supervised learning. We learn from the past data, classify new data, and then the output variable is categorized, whether it is nominal or ordinal in nature. So, and then we can provide some insights or patterns of the data. Yeah. So it is predictive accuracy is high, hit rate, and speed is very fast, is robust, scalable, and can be interpretable. So, but accuracy of classification models, there is accuracy, we can test it using what we call confusion matrix. Confusion matrix is when we look into whether it is, in terms of its accuracy, is true positive rate and true negative rate. Yeah, true positive is actually, we suspect it's positive, but it is positive. True negative, we suspect it to be negative, but it is actually negative. Yeah. And then whereas false positive is actually, we thought it is positive, but actually it is not positive. False negative is we thought it to be negative, but it's actually positive. So it's false negative. So we total true positive plus true negative, and then provide the divided by the all elements, true positive, true negative, false positive, and false negative. So we have the accuracy rate. This is the true positive rate. This is true negative rate. And then when you look into data, when you collect data, there is precision and recall. Precision is you get everything. Precise is the precision of it. I'll put more records in my video. So, and then we have, how do we estimate the methodologies? How do we test this data? In the development of this data, we have a pre-processed data. We provide 2/3 into training and then 1/3 to test this data. We develop the model and then we train them. And then we assess the model by testing the data. And then we measure it by the prediction accuracy. For neural network is we call it artificial neural network. It's a method in artificial intelligence where data is split into 3 subsets: training 60%, validation 20%, and testing 20%. Yeah, so I'm going very fast. And then this is another method of testing this data. We call it k-fold cross validation. K-fold, okay, this is 10-fold. If 8-fold, and then it will be divided by 10. It divide by 8. If it's 5-fold, it will be divided into 5. So we divide them and then we take certain data for training and testing. And then we'll do all. Yeah. There are several other methods of classification. Okay, classification technique. Other classification technique, we can include decision tree analysis, statistical analysis, neural network, or we call it artificial neural network, support vector machines, case-based reasoning, Bayesian classifier, genetic algorithm, and rough sets. I will put some more detail in my video. Decision tree is divide and conquer method. We break into the decision tree. This is best work if we have certainty, certain level of certainty. We can break in and then we test them. Yeah. So this is a decision tree, and then Cluster analysis. The difference between cluster analysis and classification is cluster analysis is unsupervised learning. Classification is supervised learning, where it still break up the data into components based on the attributes, but it doesn't have a priori clustering, meaning that there is no prior classes. So we develop classes, or we group the content, we develop cluster, or we group the content based on the attributes, identification of the attributes. Yeah, so we provide new instance. So it is not an output target variable. So in marketing, this is known as segmentation. We do segmentation. Yeah, in marketing, we call it segmentation. Yeah. Clustering result in identifying a natural group of customer, can assign new cases, provide characterization, definition, labeling of population. For example, you define what is your customer segment. We can identify your customer segment by the cluster analysis. Yeah. Analysis method include K-means, K-mods, neural network, similar just now, and then fuzzy logic and also genetic algorithm. Yeah. So it's a goal of cluster analysis. K-means, okay, this is cluster analysis. How do you determine the cluster? By Euclidean distance. Euclidean distance is similar like apply Pythagoras theorem. We learn Pythagoras theorem in our school, Pythagoras theorem. So we measure the distance between using Pythagoras theorem, but we call it Euclidean distance, this measurement of this, the distance. So with the distance, we can group the cluster. We can group the cluster of the observation. Yeah, observations. We can cluster the observations. Yeah. So using Euclidean distance. Euclidean distance is based on the matching coefficient. Yeah, or we can say similar like the Pythagoras theorem. Yeah. And then we can look into single linkage, complete linkage, group average linkage. Group average linkage meaning that the average for the group. Median linkage, we look into the median, or centroid linkage, meaning that there is a cluster, we look into centroid, the center. Yeah. Complete linkage, the whole group. Yeah. Single linkage, group by link. Okay, this is the definition of single linkage, complete linkage, group average linkage, median linkage, and centroid linkage. So clustering is about how do you develop a group or develop a cluster by grouping the observations in the attributes, in the variables. Yes, you can see this is group average linkage, this is centroid linkage, is the center, complete linkage, and single linkage. Okay, please read also about Watt's method and McVitie's method and dendrogram. Yeah, dendrogram. K means clustering is using a value of K. The algorithm we design each observation to one of the K cluster. Yeah, so please read through. I will put up the video. This is K means algorithm. K means algorithm. This we can see that develop into clusters. We break them into clusters. Break them into cluster. Okay. Okay, and then association rule. Mining association is also unsupervised learning. So we look into tendencies of people buying. Oh, for example, given here an example is market basket analysis. Market basket analysis is easiest to remember. It is a basket that you bring over to when you go to a supermarket, to a shop, or a market. So person buying item A will also buy item B. Person item buy, for example, so everybody buy item A will also buy item B. So there is association between item A and item B. So there is an example here. I think there is an example here. Okay, examples here. So this is an example. How do you develop the K-means algorithm? Yeah? So, but this is an example here. So I'll put the example in my video. Okay, it is used for cross marketing. Okay, for example here. Customer who bought a laptop computer and virus protection. So people who buy 70% of the time. People who buy laptop computer will also buy virus protection. Or for example, people buying, in my other class mentioned, people buying a burger bun will also buy a burger patty, for example. So those are association. So we can, so this provide you how you can sort your rack, sort the items in rack in your store, yeah, and so on. Association rule mining. Or you can also in medicine relationship between symptom and illness, yeah. So we can have if-then statement and so on, antecedent, consequent, and yeah. So there are several algorithms that can use for association. One is a priori, eclat, FP gross. So we'll go detail. A priori is where you find subset, yeah. And then this using k-means algorithm, for example, is SKUs, item number 1, 2, 3 here. So we can see one item data set is all one that support 3. Yeah. Item 1 supported by 3. 1, 2, 3 here. Item 2, 6 to 1, 2, 3, 4, 5, 6. And then we can group here 1 and 2, 3. 1 to 4 is 3, for example. So this is association. People who buy item 1, will also buy 2, also buy 3, supported by 3 numbers. So this is an algorithm, the algorithm, how do you look into the k-means algorithm. And then yeah, confidence level and also the relief ratio, yeah, of association. How do you evaluate the association? Text mining is part of your individual assignment where it contains information, unlike because numerical data, they have figures, but text mining is extracting useful information from text data, but text are unstructured data. So you have emails, you have letters, you have documents, so that is text data, so you need to process them to become a structured data, and then from this structured data, so there is a process where we call it tokenizing, parsing, until we have the root word, and then we measure the root word, and then only we have structured data, and when we process this data. Okay, this is another collection text mining. Respondent, this is good for customer relationship management. Okay, and then this is how you do text mining. Pre-processing text mining for analysis, text data for analysis. We have frequency term document metrics. Yeah. Okay. These are some data mining software tools: SPSS, SAS, statistical, K9, Rapid Miner, Weka, and also R. Okay. Data mining is a multi-step process, requires deliberate, proactive design and use. It the current state of art, and then it advances in terms of database technology. And then there are from, yeah, so this is data mining mix, and then data mining mistakes. Selecting the wrong problem for data mining. Very fast. I'm going too fast. Okay, anything that you want to I need to go back because I've been too fast. Anything that you're not clear about data mining today, or even the data, this the data of just now, the data model, our nature of data. Yeah.
I'm sorry, Prof.
I'm too fast today.
So, Prof, I wanted to ask you, can you hear me, Prof?
Yes, I can hear you.
Prof, I went through because you are mentioning in many occasions that this is for the group assignment and also individual assignment. So in the group assignment, he mentioned that the due date to provide the information, the assignment is the 3rd of May.
Yes,
so
3rd of May. No,
but
it should be at your last class. I don't have the timetable now. It's your group assignment, second last class.
Second last class.
I'm
Sorry
sure.
to it's not related to the class, but he mentioned due date for the group assignment. He said 03 due date 03 May 2023, 11:45 p.m. So maybe there is something.
Yes, I
that
think I will check that. I will check. Actually, it's supposed to be the second last class. 3
second
May.
round class.
Yeah, second last class.
Thank you, Prof.
Okay. Okay, on your group assignment, it is on the okay, I'll go back because you mentioned your group assignment. Yeah, so you have to develop a data dashboard, something like this. Yeah, data dashboard. But the case is the clinic, yeah, the clinic. So there are two dashboards that you need to develop. One is for the COO, one is for the clinic managers. Yeah, clinic managers. One is the COO. The clinic managers is how they allocate the staff routines. Yeah. And then for the COO is more of operations, and then you need to include the balance scorecard. Yeah, so something like this. So you can combine. So you need to identify the key performance indicator in the dashboard, and then from the key performance indicator, what are the key performance indicator which is relevant based on the case given, and then you develop you can use I will upload you a video on Excel. How do you use Excel to develop your data visualization? How do you develop your dashboard, simple dashboard? But the main point is it's not so much of the drawing, but more towards what is the KPI supposed to be there, and then how do you put the KPI there? How maybe you can put a donut, or you can put a pie chart which is relevant to the KPI that you want to show for effective management. That is your group assignment. For your individual assignment, yeah, is any question on that?
Yeah, sorry, Prof. So, so what you're expecting is also a visual aspect of the dashboard.
Yes.
But since there's no data, it's okay for us to just create any dummy data, right?
Yes, you can create any dummy data, but as long as I just want to see what KPIs that you want to it should be there. What KPI should be there?
Understand. So
Yeah.
what is important will be the KPI in terms of the title, and then the visualization itself.
Yes.
And we explain on that.
Yeah, you explain on that.
All right, noted on that. Thanks.
Okay, any question on your group assignment? I will, there are some videos that I've got from the web that I can use. You can look into your own, but I will also upload some videos that on YouTube that you can use Excel. You can use other software if you're familiar with Power BI or any software, but I will just put Excel because I think everybody is familiar. I think everybody should be familiar with Excel by now.
So Prof, sorry,
Yes.
the purpose of using R is not related to the assignment. It's
No.
more like it's extra knowledge. It's more like
It's an additional knowledge, but you can also use R. Oh yes, it's an additional knowledge because how do you develop? For example, R is one of the tools that you can use for data mining. Compared to the rest, just now we talked about the rest. The rest are expensive, but R is free. So it is an additional tool. When we talk about data mining, so you know what are the tools that you can use in data mining. But I will put some video how to use R for the descriptive analytics. So you are exposed. I just want you to expose to R, so you can use the data mining for the data mining process. So there are tools here. Where is it? Yeah, the video just putting just now. Yes, you can use R for this data mining. So it's not for your if you want to use R also you can use Shiny R. There is a package for Shiny for R, but it is not. You just use the most simplest tools that is suitable for you. Yeah, most simplest tool that's suitable for you. That is what my target is. Where is something? Yeah, so R is one of the software. For example, when you talk about Crisp DM just now, it uses R, so you can use R. So it's exposure for you to do R. And then actually next week, this is part of the another quiz for you, where you do descriptive analytics. You will do descriptive analytics, meaning that you will do the things that are provided here. Yeah. So like next week, not today, not this week, next week. But I will provide you the videos. How do you do chart? How do you do mean, median, and so on? So the items is provided here. Yeah, the method is provided here using Excel. So next week I'll give you some data case. So we will break you into group like as done previously. I'll break you into groups. You'll do in groups, and then there will be several questions that you do. So how do you do it? You can use Excel. The Excel worksheet will be provided, and then how to do this will be provided, but you just do it. And then there is option for you to use Excel and option for you to use R. And then you don't have to submit immediately. You submit your last class. You submit in your last class. So, but next week I'll just give you some half an hour or so that you can discuss with your classmates. Yeah, so you can do figures like this. Yeah.
Prof, are you referring to the data set that you've posted?
Okay, the different data set. The data set I've posted is for your guideline. Yeah, in the guideline, there are some questions in the guideline. There are questions in the guideline, so the data set supports the guideline. It's meant for the guideline. I'll show you the guideline. Do you have the guideline with you? It is in the LMS.
No, Prof. No.
No, you don't have the guideline.
Yeah, I only saw the data set, but I don't have the.
You saw the data set, but you didn't have the guideline. Okay, hold on. I'll just show you the guideline. Just I need to log in. Okay, guideline. Where is that's study guide? It's in the study guide. Okay. Hold on. I will show you. Okay. It is in the study guide. There is a study guide, course module study guide. Okay. Yeah, I'll share my screen. Share my screen. Okay, you might see differently, but it is in the study guide. This is what I see on the attachment document. There is a study guide here, and then what you should see in the study guide is something like this. Hold on, I'll share the screen. Share. Where is the study guide? No, I'll stop the share first. Okay, stop the share first. Yes, I get confused. I need to get hold on, I need. Okay, here. Study guide. Share screen. Okay, this is study guide. Can you see the study guide? Okay.
Yes,
Okay, at the
Page 38, I think, Prof.
I think, oh, you know.
I just, you told, so I was searching for it. Yeah.
Okay. There are questions that you can, for example, here. Oh, okay, I will put up the answer for this. I'll put up the answer for this. Remind me. I will put up the answer. There is an answer sheet, but I don't put in the guideline. Put it differently. Okay, this is the topics that you need to read. Yeah, the topic that you need to read in the book. Yeah, these are the topics that you need to read in the book. For today's topic, this is about that data. Okay, it's from chapter 2, in chapter 2, and CAM, I think, chapter CAM. So, but these are the topics that you need to read, chapter 2 in the book, Shada. And then the book is given in the book is given, there are 2 copies of the book. But I use the cheaper version. There is another Asian version, Asian version, something like that. Okay, this is the two. And then the question is here. Okay, these are some data set. These are data set. These are the questions. The transit data is provided there. It is in your. I think I'll just use for next week. I might just use this. We already have this. Okay. Do you want to use this data or you want to have the different data?
I think we can just use this since it's there already, right?
Okay, it's already there. So we can use this data. Next week, we can just use this data. So we can look into, say, okay, for example, the first question is about frequency distribution and bar chart. You can use Excel or you can use R. Yeah, so I will provide you the answer for R and then also provide you the answer for Excel. But you need to do because you need to submit this. I'll bring you into group. You need to do in this next week. And then here is the question on Excel at heart. How do you develop contingency table? Yeah, or do you stack column chart? Then this is on summarize the result, scatter plot. The topic that we learned today, scatter plot and so on. Yeah. The detail you look in the book. I'm still recording my video. I do portion by portion. So I put up my video, but next week only we will do this. And then, okay, this is how will you define concept or data, information, knowledge. I've given you the answer. Yeah, just now. Data are very meaningless, are very raw. Information, you integrate data, become information, and then you have include data, information, and understanding, experience, you become knowledge. Yeah. And then this is the topic on data mining. The question here on data mining is this is session analysis. So I'll provide you the answer. Advantage, disadvantage of stem plot. Next week we'll cover text web and social media analytics. I have to cover 2 topics this week, topic 3 and 4, because next week I will only cover topic 5 because then I will give you a quiz, so you will work together with your friends, and then you will submit at the end of the course, at the end of the trimester. Yeah, at the end of the trimester. But you will do it together with your friends, and I will also provide you the how to do it. The idea is to give you exposure. How do you actually understand? How do you do business analytics rather than just listening by theory? But as we go along, you will be able to appreciate business analytics as a manager. As a manager, we're not so technical, but as a manager, my goal is actually for you to understand business and how do you apply business analytics as a business manager. Because there are questions that people ask why I don't put in too much technical. This is to some this is already technical. To some this is not technical enough. But I cannot go too much technical because you are business manager. But I cannot be too less, otherwise you don't appreciate what is business analytics. So I have to balance. So as a business manager, you need to know a little bit of business analytics so that your staff will not lie to you. at least you know something. Otherwise, your staff say, "Oh, this manager doesn't know anything." At least you can show you know something as a manager. Okay. Okay. Go back to today's topic. Any question on today's topic that you are not? Okay, this is data cleansing. We still have about 10 or 15 minutes. Yeah. Tables. Okay. Okay. In terms of visualization, the idea of visualization is just to give enough. Just to give enough. Then data in ratio is by Tufti. It's about not to put unnecessary lines, unnecessary data, and unnecessary ink on your chart to make it cluttered and people don't see your data. And then whether they need precise data or not, whether you want to provide table or table or chart depends on what what the audience want to read. For example, if your audience is a CEO or board of directors, are they particular on the exact figure? Yeah, the CEO don't really particular on the exact figure. At times, yes, they want to do actual profit and so on, but they don't look at operational data. They just want to see the graph, whether you are trending going up or trending going down. So you just give enough. So in the table, you just provide enough. For example, this is lines. These are horizontal lines. Sometimes you don't need horizontal lines. You remove horizontal lines. You can see the fluctuations. You remove unnecessary lines and labels. And so does tables. Tables provide specific numerical value. So you can look into in thousands, in hundreds, in millions, or in exact details. 4, 5, 4, 6, 5, 4, 6, 5, 6, 4, 5, 8, or you just put 1,000 here for 56,000. So it depends what sort of information that you need for decision making. This is line chart, yeah. Or you can combine this, something like this. Avoid vertical line unless they are necessary. Horizontal line are used to separate the data value, yeah, the headers of the data value or column titles for the data value. Yeah, so you have comparing, so you can see design A are very cluttered, design D simple, and then more clear. Yeah, better. So you use this in your visualization exercise. Yeah. And then cross tabulation, pivot table. You can I'll explain pivot table later in your videos. Okay, this is I will provide this data later. You can play with it. The pivot table, and then chart. I think you understand scatter chart and so on. Okay, I'll move to data mining. We'll go through data mining quickly. Data mining is about looking at yes, actually looking into you have large amount of data. We have massive data. This data come from many sources. From this data, so how do you? It is about opportunity. So with the increased amount of data, with the availability of data warehouse that we have today, with the better computing power, we have opportunity to process this data so that we can gain insights. So it's more of statistics, yeah, more of statistics. So there are supervised learning and unsupervised learning. Supervised learning where we have a prior model. We have previous model that we use, previous classification. Unsupervised learning, there is no prior information. So we look into assessment, yeah, how to compare the result. So, and then this is definition data mining. Data mining is a misnomer. It's actually a data or knowledge extraction, pattern analysis, information harvesting, pattern searching, yeah. And then main patterns that we look at are association. prediction, cluster, and sequential. Yeah. Association is how does people things association with association being associated with another. For example, if you go to the market, people who buy laptop will also buy antivirus, for example, association. So the increase of laptop, there will be increasing sales of antivirus. So you can see the trend, yeah, for example, yeah. And then prediction. So how do we predict? Looking at the trend. Cluster, yeah. How do we group? How do you develop your customer segment? By clustering them and then provide ordinal or ordinal categorization or nominal categorization. Who buys your product? Yeah, so we can do class. But the difference between cluster and classification will have a prior class. Cluster doesn't have prior class. Yeah, so we have here classification, we have decision tree, neural network. It is supervised, meaning that we have a prior model. Whereas clustering, there is no prior model, it's unsupervised. Yeah, time series forecasting. This is what the application of data mining. Okay, and then data mining process. Okay, this is a common standard process. One is CRISP-BM. You can use R to do CRISP-BM. You can SEMA. You will use SAS Institute. KDD is another tool. Yeah, is another tool. So classification. Okay, this is how do you measure the accuracy of classification model. We call it confusion matrix. Yeah. This is how you test. How do you test your model? You have a model, you need to test them. So the model is correct, accurate, and then only you will use them. Yeah. This decision tree is divide and conquer. You use a training set. I'll try to put a video later. Okay. Any question? Okay, this is cluster analysis. How do you analyze your cluster? Similarity between two clusters. You have two clusters. How do you measure? Because cluster analysis is unsupervised learning. Unsupervised. So it is not okay. Classification is simple, like you understand mammals, birds, and so on. Why do we put whales and dolphins as mammals instead of fish? Because there is a prior classification. Why there is a prior classification? Because it based on their attributes. It is warm-blooded, or we call it homoeuthermic, warm-blooded, and so on. It doesn't have. It's actually they give birth, for example. So there are attributes. Yes, so there are attributes. So that is called classification. We have a prior attributes that we can base upon. But when you look into cluster, it is unsupervised learning. We group them based on what we see. Similarity between the two clusters based on the observation. We have observations and then we base on that. So we have single linkage between two clusters. We have complete linkage, group linkage. So this is the bigger single linkage between 3 and 4. Complete linkage within the far end of one cluster and the further end to the one cluster. Average linkage and then centroid linkage. Centroid means center. Yeah, so this is then dendrogram. Yeah, and then what else? Association. Most popular association is market basket analysis. Yeah, relationship between diapers and beers, for example. Then rule mining. Rule mining is association rule mining. Rule is a machine learning. There is a rule. Rule mining. Okay. Okay, this is market basket analysis. Something like this. Text mining. Text mining is part of your group individual assignment. Text is the content that cannot be, it's not numbers, not numbers. So text, they are unstructured data. For example, articles or books, no, articles in books or writing in books, letters, documents, agreements. So those are unstructured data. So you can, laws, X of laws, for example. So unstructured data. So you need to process them so that you can extract useful information.
Prof,
Yes.
talking about text mining, so referring to the individual assignment, one of the requirements was to look for cases of success stories. So can you just give an example of a success story so that maybe we know we are on the right track?
Okay, I don't remember the exact because the cases move from time to time, changes from time to time. But where do you look at? Yeah, I'll tell you where do you look at. Okay, for example, you go for SAS. SAS also have text mining, SAS, SAS Institute, or OntoText, ONTOTEX, OntoText, or you can just search for text mining software. Search for text mining software. So these software vendors, when they sell their text mining software, text mining tools, they usually provide their case studies, their success customers. Yeah, their customers. So for example, the Daimler use, for example, Google might use it, and then maybe some companies, some universities use it. So you look at the case. They will provide the case. They in selling their products, they will tell you who are their customers. And then they will tell you what does the customer use, how does the customer use their software. So that is the case that I'm looking at.
Okay, thanks, Prof.
Okay, this is text mining and data mining software. Okay, this is the one that I mentioned to you. There is a free and open source. R is at the bottom there, but R in terms of statistic is the highest there. So my idea is actually to expose you to R, so that at least if you go out there as a business manager and then you're required to do, you can use SQL, Excel, RapidMiner, or SAS, which is expensive and so on. Okay, we don't have money, we just use R. Okay, any questions? We have a few more minutes to.
Sir, just one thing. I found that the group assignments due date is still on the.
Yeah, I do not know how to change that, but I will check with the management how to change that, because earlier I thought I put it in sometime in July.
So may I know when is the actual due date for the
Actual
group
date is
assignment?
your second last class.
Second last class.
Okay, I don't remember the date, but I think I put it up there, but I'm not sure how to set it up. So I will check with the. I'm the coordinator. Actually, I will check with the staff how to change the date. It's supposed to be the second last class. Jaime just asked me just that date, the same question.
I think second last class will be around 12th of July.
Yes, I think so. Yeah,
Somewhere over there.
sometime in July.
Okay. Thanks for info. Thank you so much.
I mean, I think it will be the same day, 18 on July as
18 July.
Probably, because if you look at it, you mentioned for the individual assignment, it's 18 of July.
Yeah.
So probably it's the same day. I think it will be even better that day.
Okay.
That's what he said. I'm sorry. That's just what I said.
Yes. I have to check back, because I think I've written sometime in July, but I'm not sure how it become the May, actually the date that I put up.
No problem, sir. No problem at all.
The date is the date that I put up the assignment. Not the date is supposed to be submitted.
Okay. Thanks. Thank you so much.
Okay, any question? We have some few more minutes, 2 more minutes. Any question? Hi, me. Today we have only Jaime question. Mariam is quiet, Rebecca, Azani. I'm very sorry today because we have to cover 2 topics. I run very fast. Sometimes I overestimated my speed, underestimated my speed.
Regarding the individual assignment, can we actually choose the text mining based on our own industry?
Based on your own?
Industry.
Can.
Okay.
Can. I just want to see how do you, I want to see how do you appreciate, how do you understand text mining? How is it being applied in the market? So you know how it is being applied in the market, text mining.
Okay, thank you, Prof.
Okay. Yes, Azani, any question, Azani?
For me, I'm just should be okay, Prof.
Yeah, okay.
And this,
I owe you the video actually. In the I lecture for this class, I will put the some videos on how to use Excel and as well as R for the descriptive analytics. Yeah. And then next week we will use there is a case I think the question is already in your guideline book, but I will break into groups so you can group it with your friends, do the task, and then submit it at the end. So, but we will share because like we did last week. So we will share how do you do that. We will share to the other groups as well. Yes. So. Okay.
Sorry, Prof. Last question. You mentioned citations or reference must be made from an authorized sources. Citation from Wikipedia or any other unreliable sources
Yes.
will not be acceptable.
Yes.
So it has to be all of them journals, APA journals.
Not really journals, but you can also cite the software vendor. Journals, and also the software vendor. Okay, it's like this. My target is actually when you write about text mining, you say, okay, there are certain tools that they use. For example, they say parsing and so on. So you have reference, tokenizing. You have references. What is tokenizing? What is parsing? So you can cite that from the academic, from any academic papers.
No websites, no Wikipedia, those basic, because
website can, but Wikipedia, the issue is Wikipedia, because Wikipedia, some of the content in Wikipedia are not yet validated. Yeah, that's the reason. Most academics do not accept Wikipedia because most academias are written, Wikipedias are written by individuals like us, like everyone. You can write contents in Wikipedia, but some of the content are validated, some of the content are not validated. Meaning when it means non-validated, meaning it is not from an authorized source. Meaning if you're writing about text analytics, meaning that you should be someone who are coming from that discipline. So you cannot just write something. That's why it's not acceptable, Wikipedia. But other websites that come from genuine resources, authorized resources, it is acceptable. Okay. Same goes to ChatGPT. Yeah? ChatGPT also, they don't mention this, not specific. Okay, any other question before we adjourn? Okay, thank you very much. See you again next week.
Thank you, Prof.
Thank you, Prof.
Thank you very much.
Thank you, Prof.
thank
Good
you,
evening,
Prof.
everyone.
Good night.
Bye-bye.
Thanks.
You must be tired, Prof. Have a good rest.
Okay.
Assalamualaikum.
Waalaikumsalam warahmatullah. Thank you.